Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be looking at dividing radical expressions. And before we do, let's kind of look at the steps in the process that we're going to use today. So when you're dividing radicals, the first thing you want to do is make sure you have the same index. You can divide square roots and square roots, cube roots with cube roots. So then you're going to divide the coefficients if they exist. Then you'll divide the numbers inside the radicals, and you want to make sure your answer is fully simplified and the denominator is rationalized if possible. So what does it mean for a denominator to be rationalized? So for radical expression to be completely simplified, there can be no radical left in the denominator. If there are, we must replace the radical by a rational number by a process called rationalizing. The denominator. Now, the steps to rationalizing the denominator are identify the radical, multiply the numerator and denominator by that same radical, and simplify the resulting expression. And we'll look at an example of that in just a minute. Now, before we do, let's look at some problems where we don't need to rationalize the denominator. So in example A, we have the square root of 288 divided by the square root 6. Now, we can rewrite that as square root 288 over 6. Now, I'm going to divide 288 divided by 6. 288 divided by 6, and that gives me square root 48. And then, of course, we want to write our radicals in simplified form. So I could rewrite square root 48 as square root 16 times square root 3. And square root 16 is 4. So this would be 4 square root 3. All right, in problem B, we have 6 square root 8 over 3, or divided by 3 square root 2. So I'm going to rewrite this as 6 divided by 3 times the square root of 8 over 2. The 6 over 3 times the square root of 8 over 2. So 6 divided by 3 is 2, and 8 divided by 2 is square root 4. And then I can simplify that a little further because the square root of 4 is 2, so 2 times 2 is 4. All right, problem C. The square root of 120 x to the 9 y to the 10 divided by 5x squared y squared. So I'm going to rewrite this as, let's come over here, take 120 and divide it by 5. That would give me square root 24. X to the 9 divided by x to the 2 would give me x to the 7. And y10 divided by y2 would give me y to the 8. And then I want to break that down. So square root 24 could be written as square root 4 square root 6. Now, x to the 7 is not a perfect square, but I could rewrite it as x to the 6 times x to the 1. And y to the 8 is a perfect square, so I'll put that in my first radical. All right, so now let's simplify that. Square root of 4 is 2. The square root of x to the 6 is x cubed. And the square root of y to the 8 is y to the 4. And square root 6x is in its simplest form. So this would be our final answer. All right. Pause the video and try problem D on your own. All right, let's see how you did. I rewrote this as 8 a to the 10 power, b to the 6 power. And then I broke that down. Square root a, I broke it down into, I broke it down into 4 times 2. A10 was a perfect square, so I put that with the 4. And B6 was also a perfect square, so I put that in the first radical. And then I broke that down further to 2a5, b to the 3. times square root 2. All right, problem E. We have 3 over 9 square root 5. Now, there's not a radical on top, but I can begin by dividing everything here by 3. So 3 divided by 3 would be 1. 9 divided by 3, this would be 1 over 3 square root 5. Now, to simplify that, I cannot have a radical in my denominator, so I must rationalize my denominator. So the square root in my denominator is square root 5, so I'll multiply the top by square root 5 and the bottom by square root 5. Now, in this next step, you're going to figure out why we did that. So I'm going to multiply the top. 1 times square root 5 is square root 5. And then on the bottom, 3 square root 5 times 1 square root 5 would be 3 square root 25. Now I can simplify that a little further. The square root of 25 is 5, and 3 times 5 is 15. Now it is simplified as far as it will go. All right. In problem F, let's see, I think I can rewrite this as 4/8 times the square root of 3/18, which would simplify to 1/2 times the square root of 1/6, which I can then rewrite as 1 times square root 1 over 2 times square root 6. Now 1 times the square root of 1 is just 1. And 2 square root 6 will not simplify. So I get 1 over 2 square root 6. Now I cannot box that in as my final answer because I have to rationalize the denominator. So by rationalizing the denominator, we'll multiply the numerator by square root 6 and the denominator by square root 6. So on the top, 1 times square root 6 gives me square root 6. On the bottom, 2 square root 6 times 1 square root 6 would be 2 square root 36. So on the top, I have square root 6. And on the bottom, the square root of 36 is 6, and 6 times 2 is 12. So our final answer, square root 6 over 12. Now, in some cases, you're going to have a binomial denominator. In other words, you're going to have 2 terms in your denominator. So let's talk about what to do if that happens. So when the denominator of a radical expression contains a binomial, we must multiply both the numerator and denominator by the conjugate. So let me just review what a conjugate is. Conjugate. Okay, a conjugate would be something like square root 3 plus 2. Its conjugate would be square root 3 minus 2. Okay, just change the sign. When multiplying a binomial radical expression by its conjugate, the result will always be a rational number. So we're going to look at what that will look like here in just a second. So in problem A, it says rationalize each denominator. In other words, we're trying to get the radical out of the denominator. So to do that, I have to find the conjugate of the denominator. So the conjugate of 4 plus square root 2 would be 4 minus square root 2. So I'll multiply the top by 4 minus square root 2 and the bottom by 4 minus square root 2. All right, so for the top, we will use our distributive property here. 4 times 4 gives us 16. 4 times negative square root of 2 would be negative 4 square root 2. On the bottom, I'm going to multiply 4 times 4 minus square root 2, which would give me 4 times 4 is 16. 4 times negative square root 2 is negative 4 square root 2. Then I'm going to take square root 2 and multiply it by everything in the denominator. So Square root 2 times 4 is positive 4 square root 2. Square root 2 times negative square root 2 is negative square root 4. All right. Now I'll simplify a little further. The numerator will not simplify, so let me write that down. The denominator, I want you to notice that this term and this term would sum to 0, so those are going to disappear. And I'm left with 16 minus square root 4. Now the square root of 4 is 2. So 16 minus 2 is 14. Now, if you box that in, I would probably count it correct if you were my student, but I do want you to notice that we can simplify this fraction a little further because 16, 4, and 14 all have a common factor of 2. So if I divide 16 by 2, I would get 8. 4 divided by 2, I would get 2. And 14 divided by 2, I would get 7. So if I rewrote this, this would give me 8 minus 2 square root 2 over 7. All right, problem B. 2 plus 6 square root 5. We want to rationalize the denominator. So I'm going to multiply this by 6 minus square root 5 over 6 minus square root 5. All right, so I'm going to multiply the numerators together. 2 times 6 gives me 12. 2 times negative square root 5 gives me negative 2 square root 5. Then I'll multiply the denominators together. 6 times 6 gives me 36. 6 times negative square root 5 gives me negative 6 square root 5. Square root 5 times 6 gives me positive 6 square root 5. And square root 5 times negative square root 5 gives me negative square root 25. All right, now nothing I can do to simplify the numerator, so I'll just write that down. Let's try to simplify the denominator now. Okay, notice that your middle terms are going to zero out, and so you're left with 36 minus the square root of 25. Now the square root of 25 is simply 5. So you're left with 36 minus 5, which gives you 31. Oh, excuse me, I don't know why I put a radical symbol. It just gives you 31. So our final answer is 12 minus 2 square root 5 over square root 31. All right, 3 plus the square root of 2 over 2 minus the square root of 2. So I'm going to multiply the top by 2 plus square root 2 and the bottom by 2 plus square root 2. All right, so I'm going to multiply 3 times everything in the numerator. So 3 times 2 gives me 6. 3 times square root 2 is 3 square root 2. Now I'm going to multiply square root 2 times everything in the numerator. So that would give me 2 square root 2 plus square root 4. Now on the bottom, I have conjugates. Now remember, when you multiply conjugates, the two middle terms disappear. So really, I only need to multiply the first times the first and the last times the last. So 2 times 2 is 4 minus square root of 4. Okay. Now let's simplify that up. So in the numerator, the square root of 4 is 2. So 6 plus 2 would be 8. And 3 square root 2 plus 2 square root 2 is 5 square root 2. So that's the numerator for me. And then on the bottom, the square root of 4 is 2, and 4 minus 2 is 2. So we have 8 plus 5 square root 2 over 2. All right, problem D. 3 plus square root 6 over 5 minus square root 24. So I'm going to simplify that denominator real quick. I'm going to leave the numerator as is. But square root of 24, let me write that down, could be rewritten as square root 4 times square root 6, which is the same thing as 2 square root 6. I'm going to rewrite the bottom as 5 minus 2 square root 6. And I just feel like if we work with the 24, it's going to make the numbers too big. So we have 3 plus square root 6 over 5 minus 2 square root 6. And I want to multiply by the conjugate. So the conjugate would be 5 plus 2 square root 6 over 5 plus 2 square root 6. All right, let's multiply the numerators together. 3 times 5 is 15. 3 times 2 square root 6 would be 6 square root 6. And then square root 6 times 5 would be 5 square root 6. And square root 6 times 2 square root 6 would be 2 square root 36. On the bottom, because we're multiplying conjugates, I only need to multiply the first term times the first term, which give me 25, and the second term times the second term, which would give me negative 4 square root 36. All right, now let's clean this up a little bit. Here, the square root of 36 is 6. So we're doing 15 plus 2 times 6, so 15 plus 12 would give me 27. 6 square root 6 plus 5 square root 6 would give me 11 square root 6. And on the bottom, the square root of 36 is 6. So this is 25 minus 24, which would be 1. So really, your final answer here is just 27 plus 11 square root 6. And that concludes today's lesson on dividing radical expressions.